Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 9 video on the chapter of squares and square roots where I will solve the test paper 3 which is given at the end of the chapter in the textbook of author RS Aggarwal. So this test paper has 13 problems. These are not MCQ. You have to these are mostly subjective and some are fill in the blanks and some are true or false. There are approximately 13 problems and you should be able to complete these 13 problems in 45 minutes to 60 minutes. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you have not watched the previous 8 videos, part 1 to part 8, where I have covered all the theoretical concepts of the chapter squares and square roots, I strongly suggest that you watch them to have to have a better preparation on the chapter of squares and square roots. Recently, I have also solved the objective questions, that is exercise 3H from the textbook. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time or seeing this video for the first time and my video is beneficial for you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the test paper 3. Okay, so I have the test paper 3 on the left hand side, and on the right hand side I will solve the problems. As and when required, I will try to elaborate on the concepts that I am applying to solve a problem. So there are 13 problems divided into 3 sections, A, B and C, and some are section B is MCQ. Okay, section B is MCQ, section C is fill in the blanks, and section A is subjective problems. Okay, so let's start solving the problems. Section A, problem 1 is we have to evaluate the square root of 11236. Now you have primarily two important methods by which you can find the square root of a given natural number, that is prime factorization method, or you can also use the long division method. I think the long division method is a very general purpose method where you can find using which you can find the square root of any kind of numbers. It can be a perfect square, it can be a non-perfect square, it can be a decimal number, fractions, whatever. So I will prefer to find the square root using the long division method. So I have the number 11236. We have to create or mark the periods, that is 2 digits at a time. 2 digits make a period starting from the right hand side. So 36, 12 and 1 are the 3 periods. Now we will start from the leftmost period, that is 1. So obviously the 1 will be the divisor, 1 1, and we have the remainder 0. Then we bring down the next period, that is 1 2, that is 12, and append it to the remainder, and which now becomes the next dividend. So 12 is the next dividend, and the next divisor or the partial divisor will be whatever the current quotient is multiplied by 2. So 1 multiplied by 2 is 2. Now I have to find the digit x such that the 2-digit number 2x multiplied by x should be less than equal to the dividend, that is 12. So obviously x should be equal to 1. The largest x, always remember that in doing the long division method, when you have to find this digit x such that 2x, the 2-digit number 2x multiplied by x is less than equals to 12, the x should be the largest possible digit. We cannot take x2 because 22 into 2 is 24, which is exceeding 12. So x will be 1. Okay, so x will be 1. I am writing x, and x will be 1. 1 will also be added to the quotient, and 21 multiplied by 1. So you have to do 21 multiplied by 1 is obviously 21. So we have 21, which will be subtracted from the current dividend. Wait a second, what is happening? uh, 0, 1, 2, 2, and it will not be 1. Sorry, it will not be 1 because it is the dividend is 12 and the dividend is 12. It will not be 1. What I am doing, the dividend, we have to find the digit x such that the two digit number 2x multiplied by x less than equals to 12 has to be less than equals to 12, and we have to find the largest x. Now x cannot be even 1. If x is 1, 21 into 1 is 21, it is exceeding 12. So x has to be equal to 0. X has to be equal to 0. So x is 0 and we will append 0 in the question, and definitely 20 multiplied by 0 is 0. We have 0 and the remainder is still remainder is 12, and then we bring down the next period, append it to the remainder, and we get the next dividend as 1236, and the next partial divisor will be whatever the current quotient is, 10 multiplied by 2. So 10 multiplied by 2 is 20. Now again we have to find the digit x such that the 3-digit number 20x multiplied by x, this will be less than equal to 1236, and it has to be the largest x. Now I think this is x will be 3, which makes 203 multiplied not 3 but 6. X will be 6, because if we have x6, we have 206 multiplied by 6 is exactly 1, 2, 3, 6. So x will be 6. So I am rubbing x here, x will be 6. 6 will be appended to the question, and definitely 206 multiplied by 6 is 1, 2, 3, 6. The remainder is 0, and there are no more periods. So we have the square root of 1, 1, 2, 3, 6 is equal to 106. 106 is the square root of the given number. Okay. So while I am solving the problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will be beneficial to you as future reference. Okay, let's do problem number 2. Find the greatest number of 5 digits which is a perfect square. What is the square root of this number? We have to find the greatest number of 5 digits which is a perfect square. Okay, so first, greatest 5 digit, we have to find the perfect square which is a greatest 5 digit number. Greatest 5 digit number which is a perfect square. So we know that the greatest 5, we will start from the greatest 5 digit number, which is equal to 9, 9, 9, 9 and 9. Okay, now to find the greatest 5 digit number which is a perfect square, definitely we cannot add 9999. This number is not a perfect square. So either we have to add something to it or subtract something to it. If we add something to it, add something to 5 nines, then definitely the number will become 6-digit number. But we have been asked to find the greatest 5-digit number which is a perfect square. So definitely we have to subtract something from this number which will be a perfect square. So we know that we have done a question where we are asked to find the least number that need to be subtracted from a given number to make it a perfect square. So we have to now this question boils down to that pattern of question. So we have to find the square root of how much is this? This is 99,999. We have to find the square root of this. So we mark the periods 9, 9, 9, 9 and 9. So definitely first it will divide by 3. 3 into 3 is 9. the remainder is 0. We bring the next period, that is 99, and then we divide. The next partial divisor is 3 into 6, 6, and then definitely it will be 1. 1 will be appended to the question. 61 multiplied by 1 is 161. We subtract 61 from the dividend 99, and it is 38, and then we bring down the next period, append it to the remainder. So the dividend becomes 3899, and then we proceed with the long division, and the next partial divisor is the current question multiplied by 2. So 31 multiplied by 2 is 62, and now we have to find x, the digit x, such that the 3-digit number 62x multiplied by x is less than equal to 3899. We have to find the largest x. So what can x be? Now if we take x as 6, let's see what happens. Can we take 7? No, we cannot take 7, because it will exceed definitely 6, 7, 42, it will exceed 3899. So let's try out with 6. So 6, 6, 36, 15, and 3, 7, 5, 6. So 6 is the maximum number, so such that 626 multiplied by 6 will be less than equal to 3899. So x will be 6. So we put 6 over here. We also append 6 to the question, and 626 multiplied by 6 is 3, 7, 5, 6, and the remainder is 3, 4, and 1. Okay, so since there are no more periods left, so the remainder is 143, and we know that we have to subtract. We know that when we do a long division and we have, for finding the square root, we have a remainder 143 and the question is 316. This implies that 316 whole square plus 143, that is a remainder, is actually the given number, that is not given number, but the greatest 5-digit number, that is this number. Okay, so from here we clearly see that the greatest 5-digit number, now we can see that the number, the perfect square, which is the greatest 5-digit number, has to be 5-digit number. So clearly we see that 316 whole square is equal to the greatest 5-digit number minus 143. 143 was the remainder of the remainder while finding the square root of the greatest 5-digit number. Okay, now this implies that we have to find the list, find the greatest number of 5 digits, which is a perfect square. So this implies greatest 5 digit perfect square has to be equal to the greatest 5-digit number minus 143, because we can clearly see that the greatest 5-digit number minus 143 is 1316 whole square, which is a perfect square, and the 143, the remainder, is always the least number that need to be subtracted from the greatest 5-digit number to make it a perfect square, and hence after subtracting 143 from the greatest 5-digit number, whatever the number is, that will obviously be the greatest perfect square of 5-digit. So this is equal to, we have to find, this is 6, this is 5, this is 8, 9, 9. So 99856 is 99856 is the greatest 5-digit perfect square. So this is the first answer, first part. It has two parts, the question. Find the greatest number of 5 digits which is a perfect square, and what is the square root of this number. We can clearly see that the square root of the greatest 5 digit number which is a perfect square is 99856, and 99 and the square root of 99856 is nothing but 316, is 316. So the answer are 99856 and 316. 99856 is the greatest 5 digit number which is a perfect square, and the square root of that number which is a perfect square is 316. Okay. So I will quickly check whether I have found the square root correctly or not. 316 multiplied by 316 is 99856. Okay. Let's do the question number 3. It is asking, find the least number of 4 digits which is a perfect square. What is the square root of this number? We have to find this time the least number of 4 digits. Okay. So we will start with the least number of 4 digits. Least 4 digit number is 1000. This is the least 4 digit number. Now we have to find the least 4 digit number which is a perfect square. We know that 1000 is not a perfect square. So either we have to add something or we have to subtract something to get the nearest perfect square. Now if we cannot subtract anything from 1000 because then the number will become 3 digit. We definitely have to add something to 1000 so that that number will be a perfect square. Okay. Now let's we have to find the square root of 1000. So 1000, we mark the periods and we do the long division. So we have the leftmost period as 10. Certainly the first divisor will be 3, 3, 9, remainder is 1. We bring down the next period 0, 0. The next dividend is 100. The next partial divisor will be 2 multiplied by the current quotient. Current quotient is 3. 3 multiplied by 2 is 6. So definitely we will have to add the digit 1. 1 will gets appended to the quotient and we have 61. So we have 39 and there are no more periods. So we see that in the long division the square root is coming out. Long division of finding the square root of 1000, we see a remainder of 39 and the quotient is 31. So this will imply that definitely you must always understand and remember that this implies 31 square is less than the given the 1000, and 1000 will be less than 32 square. 1000 will be less than 32 square. So why 32 square? And 32 square is the next perfect square after 31 square. Now the number is the least 4 digit number is 1000, but and 31 square is short of 1000 by 39. So definitely the perfect square 4 digit perfect square will be some number, so that we have to so the least number that must be added to 1000. We have to find the least number that need to be added to 1000 so that that number becomes a perfect square, and that perfect square has to be 32 square, because after 31 square the next perfect square is 32 square. So from this logic we can say that least 4 digit perfect square is equal to 32 square is equal to 32 square. And the question is also asking what is the square root of that number. So definitely the least 4-digit number which is a perfect square is 32 square, and definitely its square root is 32. So 32 why my machine is running so slow. 32 square is equal to, I will quickly do find the 32 square, even though you must be familiar in finding the square of a number, 2-digit number, quickly by some shortcut methods like column method or any other diagonal method. This is 64 and this is 96. Okay, so it is 1024. So 1024 is the least 4-digit number which is a perfect square, and the square root of this number which is a perfect square, that is the square root of 1024, is definitely 32. So these are the answers. Okay. Question number 4. We have to find the square root of a decimal number. Now, in the previous video that I very recently, a few hours back, I uploaded, which was on solving the MCQ question, that is exercise 3H. There I solved a problem to find the square root of a decimal number using the method I used in my notes or in my theoretical video, which is I would like to convert the given number, decimal number, to a fraction, so that the denominator is a even power of 10, and then I will find the square root of the numerator of that fraction, and whatever that square root is, I will divide that by 10 to the power something, 10 to the power m, where m will be whatever the power of 10 is in the fraction part. Okay, let me first evaluate this using the normal method, which is given in the textbook, that is using the long division method. So if you are using the direct long division method to find the square root of a decimal number, what you have to consider is that you have to see that there should be even number of digits after the decimal point, and the number given is already having even number of digits after the decimal point. So 2809, there are 4 digits after the decimal point, which is even. So we need not do anything else. If the number of digits after the decimal point was odd, we had to add a 0 to make it the number of digits even. Now, okay. So we need not do anything because in this number, the number of the decimal places is already even, which is 4. So we mark the periods from the right hand side, 0, 9, 2, 8, and 0 is left alone. So the first divisor will obviously be 0, 0. We have 0, and the remainder is 0, and we have exhausted all the digits before the decimal point. So we have to put the decimal point in the question. Now we bring down the next period, that is 2, 8, and append it with the remainder. The remainder was 0. So the new dividend becomes 28. Now we have to find the next divisor. The next divisor, partial divisor, will be whatever the current quotient is multiplied by 2, ignoring the decimal point. So the current quotient is 0 point. 0 point means 0.0. If you ignore the decimal point, it will be 0. 0 multiplied by 2 is 0. 0. Now we have to find the digit x such that the 0x, the 2-digit number 0x, which is basically x, 0x into x should be less than equal to 28, and the x should be maximum. The maximum digit x such that the 2-digit number 0x multiplied by x should be less than equal to 28. From here we can say that this implies that x is definitely 5. So x will be 5. Okay, I am rubbing x and putting 5, and the 5 will also get appended to the question. So I have 5 over here, and 5 multiplied by 5 is 25. I subtract 25 from the current dividend, and I get remainder 3. Now I have more periods left. I have 09 periods left. I will bring down the next period, that is 09, and append it with the remainder 3. So the next dividend becomes 309, and the next partial divisor will be the current question ignoring the decimal point multiplied by 2. So 5 multiplied by 2 is 10. Now again I have to find the digit x such that the 3-digit number 10x multiplied by x is less than equal to 309, and the x should be the maximum digit x such that 10x multiplied by x is less than equal to 309. So this implies x is equal to 3, because 103 multiplied by 3 is 309. So x will be 3, and we also append 3 with the question, and 103 multiplied by 3 is 309, and the remainder becomes 0, and there are no more periods. Therefore, the long division is complete, and the quotient will be the square root, that is the square root of 0.2809 is equal to 0.53. This is the square root. If you understand this process of using directly the long division method to find the square root of a decimal number, it is quite straightforward and easy. The only thing you have to keep in mind is that the given decimal number, if it has odd number of digits after the decimal point, you have to add a 0 to make it even number of digits, and then you mark the periods from the right hand side, and then you proceed normally with the long division method. Okay, let's solve question number 5. Evaluate square root 3 up to 2 places of decimals, that is, there will be 2 digits after the decimal point in the square root. Places of decimal. Now, to find the square root of a given number up to a given places of decimal, we know that the strategy is that if you are asked if n places of decimals, if we are asked to find the square root of a decimal number or any number up to n places of decimal, then we must have n plus 1 periods after decimal point, and if it is not so, then you have to append required number of zeros, so that you have n plus 1 periods after the decimal point. Now, so the number is 3, and we have to find the square root of 3 up to 2 places of decimals. So for 2 places of decimals, we see that 3.03 point, we know that 3 is nothing but 3.0 in the decimal form. We see that after 0 there is 1, after decimal point there is 1 0. So to find the square root up to 2 places of decimals, we need 2 plus 1, 3 periods after the decimal point. So to make 3 periods after the decimal point, what we have to do is we have to append the required number of zeros. So this makes the first period, another two zeros makes the second period, another 2 zeros makes the third period. So now we have after the decimal point 3 periods, and all the periods are zeros, and we are left with the number, the digit 3 before the decimal point, and that will be a single period. Now we have marked the period, we will proceed with the long division method. Okay, so the leftmost period is 3. Obviously, the divisor will be 1, 1, 1, and we have remainder 2. Now we bring down the next period, which is 00, and append it with the remainder 2, so that the new dividend becomes 200. Now the next partial divisor will be whatever. Now at this point we have exhausted all the digits before the decimal point, so we have to put a decimal point in the question. Now the next divisor, partial divisor, will be the current question multiplied by 2, ignoring the decimal point in the question. So the question ignoring its decimal point is 1. 1 multiplied by 2 is 2. So now we have to find the x, the digit x, such that 2x, the 2-digit number 2x multiplied by x should be less than or equal to 200, and the x should be the largest x. So largest x such that the 2-digit number 2x multiplied by x should be less than or equals to 200. So this implies what can be x? X will be equal to, can it be 8? No, it cannot be 8, 7. I think it will be 7. 27 multiplied by 7 is 49 and 18. You can also check out that 8 will not be x. X will not be 8, because 28 multiplied by x is 64, 8, 16 and 22. It is exceeding 200. So x will be 7. So now we know that x will be 7. I will put 7 over here. 7 will be appended to the question, and we know, and I know 27 multiplied by 7 is 189. I will subtract 189 from the current dividend, and the remainder is 11. And I will bring down the next period, which is again 00, append it with the current remainder 11 to have the new dividend as 1100. Now the next divisor will be whatever the quotient is, ignoring the decimal point, multiplied by 2. So 17 multiplied by 2 is 34. Again we have to find the digit x such that the 3-digit number 34x multiplied by x should be less than or equal to 1100, and the x should be largest x. What can be the largest x such that the 3-digit number 34x multiplied by x is less than or equal to 1100? And what can be x? What will be x? X cannot be 3. X cannot be 3. Can it be 3? Let's see. 3. X cannot, definitely x cannot be 4. So x, let's try out if x can be 3 or not. So 343 multiplied by 3 is 9, 12, 1029. Okay, x can be 3. So x is 3. So x is 3. We write 3 over here, and we append 3 to the question, and 343 multiplied by 3 is 1029. We subtract 1029 from the current dividend, and the remainder becomes 71. Okay, the remainder is 71, and we bring down the next period, which is the last period, append it with the current remainder, and we get the 7100 as the next dividend. And the next divisor will be whatever the quotient is, ignoring the decimal point, multiplied by 2. So 173 multiplied by 2 is 6, 346. So now we have to again find the digit x such that the maximum digit x such that the 4-digit number 346x multiplied by x should be less than or equal to 7100. 7100, but we did not find, we can stop the long division method at this stage, because we have already got 2 places after the decimal point. After the decimal point we already have 73, but in the book the way it is done, that it will find the square root up to 3 places, and then it will round off the square root by ignoring all the digits after the in the decimal part, ignoring all the digits after the first 2 digits after the decimal point. So we can clearly see that the answer will be 1.73, but let's see Let's do this the current division at least. So what can be x? 346x multiplied by x has to be less than or equal to 7100 and x has to be maximum. What can x be? Can x be 3? No. 2. Yeah, I think x will be 2. X cannot be 3. So 3, 4, x 3462 multiplied by 2 is how much? 4, 12, 9, 6924. So x will be 2. X will be 2. 2 gets appended to the question, and 3462 multiplied by 2 is 6924, and the remainder is 6, 7, 176. So at this stage we can stop the long division method, and we see that the square root of 3 is coming out to be 1.732, and we will consider, we have been asked to find the square root up to 2 places of decimals, so we will consider only the 2 places after the decimal point. So the final answer is 1.73. So the square root of 3 up to 2 places of decimal is 1.73. Okay. Let's solve question number 6. We have to evaluate square root of 48 divided by square root of 243. Now 48 is definitely not a perfect square, and 243 I'm not sure. Okay, so 243 is also not a perfect square. We know that any number, if it ends with the digits 2 or 3 or 7 or 8, is not a perfect square. So definitely we can say that 48 and 243, none of them are perfect square. So for finding this kind of expressions, what we do is we write it as square root of 48 by 243, and if we do some cancellation, there is a high chance that 48 by 243, this fraction, will get simplified to a form a by b, where both a and b will be perfect squares. So let's see what is 48 by 243. I can definitely 48, 8686, 48, 863. Okay, so it divides, dividing both the numerator and the denominator by 3, we get 81 and 16. So now we can see that this is equal to square root of 16 by 91, and we see that 16 by 91 in the fraction, in the simplified fraction 16 by 91, both the numerator and the denominator are perfect squares. So we will now express it as root over 16 divided by root over 91. The concept is that for any two positive numbers, we always have square root of x by y is equal to square root of x divided by square root of y. So as per our convenience, we can always express in either form. The result will be same. So now this will be 4 by 8. Sorry, 4 by 9. 4 by 9. So the answer is 4 by 9. Okay, let's do section B. These are MCQ questions. Question number 7. Which of the following numbers is not a perfect square? Which of the following numbers is not a perfect square? We know that any number which is ending with the digits 2 or 3 or 7 or 8 is not a perfect square, and any number which is ending with an odd number of zeros is also not a perfect square. So definitely the choice is correct choice is D, because for D the given number is ending with the digit 2. So 1,222 is not a perfect square. So the correct choice is D. Okay. As 1, 2, 2 ends with the digit 2. Okay, let's do problem number 8. So we have to find the square root of a mixed fraction, that is 2 and 1 by 4. So this is equal to, if we convert the mixed fraction to an improper fraction, it will be 9 by 4, and we see that 9 by 4 is a fraction where both the numerator and the denominator are perfect squares, so we can express it as square root of 9 by square root of 4. This is equal to 3 by 2. The answer is 3 by 2. So the choice will be, now 3 by 2 is the answer, and 3 by 2 we have to express it in mixed fraction form, because all the choices given are in the mixed fraction form. So 3 by 2 is nothing but 1 and half. So the correct choice is C. C is the correct choice. Okay, let's do problem number 9. 9 says that which of the following is the square of an even number. So we know that if a square number is even, it has to be the case that the number whose square is that square also has to be an even number. That is, the square of an even number is an even number, and the square of an odd number is an odd number. That is the main concept. So the question is, which of the following is the square of an even number? Now the square of an even number has to be an even number, so we have to choose the choice which is an even number, and the obvious choice is choice C, as 1, 7, 6, 4 is even. This is the reason. Okay. Question number 10. What least number must be added to 521 to make it a perfect square? What least number must be added to 521 to make it a perfect square? Okay. So we know we have to find using the long division method the square root of. We have to perform the long division method to find its square root. So we mark the periods 21, 5, and we have 2, 2, we have 4, remainder 1. We bring down the next period 21, and then the dividend is 121. The next partial divisor is 2 into 2, 4, and what will it be here? 2, 3. So it will be 2, and we append 2 over here, and we have 84. So the remainder is 7, 37. So 37. So it is asking what least number must be added to 521 to make it a perfect square. What least number must be added? Okay. So we know that when we do a long division in finding the square root of a number, the question is if there is a remainder. If there is a remainder, we know that 22 square, the given number whose square root we are finding, will lie between the square of the quotient and the square of the quotient plus 1, that is 23 square. Now so the least number that must be added, so the least number, so the number, if so the least number, so definitely it is asking what a number must be added and what must be that least number is. So something must be added to 521. Now we clearly can see that the next square number has to be 23 square, because 521 is lying between 22 square and 23 square. So definitely the next number greater than 521, which is a perfect square, has to be 23 square. So therefore the least number to be added will be definitely equal to the next square number, that is 23 square minus the given number 521. This will be the least number that must be added to 521, which will effectively make that number to be 23 square, which is a perfect square. So we have to find what is 23 square. 23 multiplied by 23, 9, 6, 6, 4. So this is 5, 2, 9. So 5, 2, 9 minus 5, 2, 1, which is equal to 8. 8 is the number that must be the least number that must be added to 521 to make it a perfect square is 8. And if you add 8 to 521, it will give 529, which is nothing but 23 square. So the answer is 8, and the correct choice is D. Correct choice is D. Okay. Question number 11. Question number 11. What least number must be subtracted from 178 to make it a perfect square? So you must be very familiar with all the patterns of question. So these are very standard patterns of question, and you must be by seeing the pattern of the question, you must be fast enough to know what you have to do, how to solve the problem. So it is asking what is the least number that must be subtracted from 178 to make it a perfect square. So we will find the long division method. Whatever the remainder will be, that will be the least number that must be subtracted from 178. So let's do the long division method for 178. So we have marked the periods 78 and 1, and obviously we have to start with 1, 1, 1, 1, remainder is 0. We bring down the next period 78, the next dividend becomes 78. Now the next partial divisor will be the quotient multiplied by 2, that is 2, and now we have to find the digit x, so that the 2-digit number 2x multiplied by x is less than equal to 78, and the x has to be maximum. The maximum digit x such that the 2-digit number 2x multiplied by x has to be less than equal to 78. So this implies x has to be equal to, x cannot be 4, x has to be 3, and 23 multiplied by 3 is 69. So x will be 3, and 3 will also be added to the question, and we get 23 multiplied by 3 is 69, and the remainder is 9, and there are no more periods. Okay, so the remainder is 9. So we know that this implies least number to be subtracted from 178 is 9, and 178, when you subtract 9 from 178, the result will be nothing but the square of the quotient in the long division, that is 13 square. So 9 is the answer. So the correct choice is C. Correct choice is C. Okay, let's do problem number 12. Let me quickly check if everything is visible or not. Okay. Question number 12. So we have to find the square root of 72 multiplied by the square root of 98. We know that there is another property of square root. There are two properties of square root that you should remember. The first one is that for these two properties only holds for two positive numbers x and y. So we have root over x multiplied by root over y is equal to root over square root of x multiplied by y. So square root of x multiplied by square root of y is equal to square root of xy. And the second one is that square root of x by y. So x by y is a fraction. Since x and y are both positive numbers, x by y is equal to root x divided by root y. So now we see that 72 and 98, they are not perfect squares as they are ending in the digits 2 and 8. So any number ending with the digits 2 or 3 or 7, 8 cannot be a perfect square. So what we do is we will express it as square root of 72 multiplied by 98. Now if we do the factorization of the numbers, we can see that 72 is 8 into 9 and 98 we can say it is 49 into 2. From here we will definitely find we have to factorize, we have to pair, from all the factors we have to create factors of squares. Okay, so 8 we have 8 and 2, so 8 into 2 is 16, and we have 9 and we have 49. Now this is nothing but 16 is 4 square multiplied by 9 is 3 square and 49 is 7 square. So we can say this is equal to, from the laws of exponents, you must know that x to the power m multiplied by y to the power m multiplied by z to the power m is equal to x multiplied by y multiplied by z, this whole raised to the power m. So we can say this is 4 multiplied by 3 multiplied by 7 whole raised to the power square. So this is, we can say that this is nothing but 4 multiplied by 3 multiplied by 7, which is 84. Now how come we got this? Always remember that the square root of a square, the square root of a square of a number. So inside the square root we are having the square of a number x, and if you take the square root of a square of a number x, the result is the number x is itself. Okay, so the correct choice is B. The correct choice is B. Okay, now let's do section C, which are fill in the blanks. The first one is the sum of, we can see that sum of sum of consecutive odd integers. So 1, 3, 5, 7, 9 and 11, these are all odd integers, odd positive integers. Also there is 13. So how many odd positive integers are there? 1, 2, 3, 4, 5, 6, 7. So this is equal to the sum of first, how many? 1, 2, 3, 4, 5, 6, 7. First 7 odd positive integers, and we know that the sum of first n odd positive integers is equal to n square. So this will be equal to 7 square, which is equal to 49. So the answer is 49. Part 2, we have to find the square root of 1681. Now it's a 1681 is a natural number. Now it is ending with 1, so definitely it will be it could be a perfect square. Now should you use long division method or prime factorization? It is up to you, whichever method is convenient for you. Now for this kind of problem where it is just asking to find the square root and nothing is mentioned about find the square root up to 2 or 3 places of decimals, it is quite possible, it is most likely that the number 1681 will be a perfect square. So you can try out quickly with the prime factorization method and see what is whether it's a square number or not. And if it is a square number, you can quickly find the square root also using the prime factorization method. Now it is ending with 1. So if it is a perfect square, then it will definitely be a square of either it has to be square of the number whose square is 16181. That number will either end with 1 or 9. So now this number 1681 is not divisible by 3. It is also, let me see, it is divisible by 9 or not. 9. No, it is not also divisible by 9. Is it divisible by 7? 14. No. 9. 7. 61. No. Now this is where I get stuck. I mean, I sometimes really don't understand what with what prime number should I start. Can it be 11? Okay, so it can be the prime factors. 2, it is not divisible by 2, it is not divisible by 3, it is not definitely divisible by 5, so it is not divisible by 7. So the next number I can try is 11. Let's see if it is divisible by 11 or not. 11, 1, 5, 58, 55, 31. No, it is not divisible by 11. Let's see with 13. 13, 58, 226, 38, 26, 8. No. 17. 17. No. 19. 21. I think it would be much easier if we use the long division method. We mark the periods and we know the first divisor will definitely be 4, 4, 4, 16, 0. We bring down the next period, 81, and the dividend becomes 81. The next partial divisor becomes 4 into 2 is 8, and it is 1. So definitely it is 41. Okay. Okay, so it was super easy with long division method, and which I could not figure it out in the prime factorization method. Okay, so 0. Anyway, so we can see that root over square root of 1681 is 41. Okay, fine. So 41 is the answer. Part 3. You must be, it is very recommended that you must be very comfortable with the long division method in finding the square root of any numbers, whether it be a perfect square, a natural number, or a fraction, or even a decimal. Super important for finding the square root of a number up to 2 or 3 places of decimals. Part 3 is the smallest square number exactly divisible by 246 is. Okay, so this is also a typical pattern of question, whether you have to find the least square number divisible by some given numbers. So the given numbers are 2, 4, 6. We know that the least number, we have to start from the least number divisible by all the given numbers, divisible by 2, 4, 6 is nothing but LCM of 246. That is the least common multiplier of 246, which is nothing but 12. So the least number which is divisible by both 2, 4 and 6 is 12. From there we have to start hunting for the least number which is a perfect square and divisible by 2, 4, 6. So what we do is the least number which is divisible by 2, 4 and 6 is 12. Now 12 we know is equal to 2 into 6. Now from the 12 we have to do prime factorization, and we see 12, its prime factorization is 2 multiplied by 2 multiplied by 3. From there we have to create pairs of equal factors. We have one pair, this, and one pair, this. So now if we just remove 3 from the prime factorization, we get 4, which should be the we have to the least number which will be a perfect square and also divisible by 2, 4, 6. We see that the LCM of 2, 4, 6, that is the least number that is divisible by 2, 4, 6 is the LCM, which is 12. Now the factorization of 12 is 2 into 2 into 3. So we have to multiply this factorization with something so that it becomes a perfect square. Now we know that in the prime factorization we are already having one pair of equal factors, 2 into 2. Now if we multiply this with 3, we get 2 multiplied by 2 multiplied by 3 multiplied by 3, and we have two pairs of equal factors, which makes it a perfect square. That is, this is nothing but 2 into 3 square. So the smallest square number exactly divisible by 246 is 2 multiplied by 3 square, that is 6 square, that is 36. So the concept is, for solving this kind of problem, you have to find the LCM of the given numbers, which will be the least number which is divisible by all the given numbers. Now from the LCM you have to find the prime factorization. In the prime factorization you have to see what numbers what least numbers you need to multiply that prime factorization to make it a perfect square. That is, by what least numbers, if you multiply it, you will get pairs of equal factors. And once you multiply that least number and you get a pair of equal factors, from the pair of equal factors you can now easily get the least number which will be a perfect square and also divisible by the given number. So in this problem that is 36. Okay. Part 4. A given number is a perfect square having n digits where n is odd. Then its square root will have a given number is a perfect square having n digits. Where n is odd. Then its square root will have. Now there is a concept. It was not there in the textbook of RS Aggarwal, but there is a concept that and the concept regarding the number of digits of a perfect square and its square root. So let's say if let x square equal to y, where x and y are positive integers. Now the concept is that so x is the square root of, this also implies that square root of y is x. square root of y is x. Now, let also my machine is really running slow. Let n be the number of digits in y. Let n be the number of digits in y, and y is the square of x. That is, x is the square root of y. So if n be the number of digits in y, then we will have the concept is, or the result is, then if then number of digits in x, then the number of digits in x will be equal to n by 2 if y is even, and it will be n plus 1 by 2 if y is odd. So this is also a very important concept that you must know regarding a number which is a perfect square and its square root. So if we have x square equals to y, that is y is a perfect square, that is y is the square of x, or the square root of y is x. So now if x and y are positive integers, now if n is the number of digits in y, that is the n is the number of digits in the perfect square, then what we can say about the number of digits in the square root, that is x, square root, the number of digits in the square root of the perfect square. In this case, the perfect square is y, the square root is x. That is why we are having x square equals to y, or square root of y is x. Now, if we assume that n is the number of digits in y, that is a perfect square, then what we can say about the number of digits in the square root, that is x. So, number of digits in x will be equal to n by 2 if y, that is a perfect square, is an even number, and the number of digits in x will be n plus 1 by 2 if y is the perfect number, that is y is odd. So it is given in the problem that a given number is a perfect square having n digits where n is odd, then its square root will have n plus 1 by 2 digits. This is the answer. So this brings to an end in solving the test paper 3. I hope this video will be beneficial to you in understanding some standard patterns of question and how to solve them using all the concepts we have learned from the chapter of squares and square roots. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future video. So with this test paper, it comes to an end in the chapter squares and square roots. And next, I will prepare two sample test paper number 1 and paper 2, that will consist of 10 to 15 multiple choice questions, MCQ questions, which ideally you should complete in 45 minutes or 60 minutes. These problems will be a little harder from what we have solved so far from the textbook of author RS Aggarwal. So please stay tuned for the next two videos where I will solve the test paper number 1 and 2 on the chapter of squares and square roots. So thanks for watching, and until the next video, take care and bye.